Let me ask you a simple question. How many hours are you at school? I received answers like this. The question was, how many hours are you at school? And I've seen answers that have been putting random units. Alright. How fast should you drive on 1277? 55 what? I've seen answers where the question asks how fast should you be doing, and 55 hours. Is that the right answer? So for speed is going to be some distance unit over some time unit, such as meters per second, feet per second, feet per minute, miles per hour. So we're going to have some distance unit over some time unit. Also, M is for meters. MI is for miles. MIN is for minutes. I've seen some answers where people had put in M divided by M when they meant to put miles per minute. Also, lowercase a is for acceleration. Capital A is for amps. If you see me put a lowercase letter, you should also put a lowercase letter. If you see me put a capital letter, you should put a capital letter. Some people have also put, for example, kilometers per second, like this. That means absolutely nothing in science. Kilometers per second. Kilometers should be km. The only exception is for miles per hour. For some reason, we occasionally abbreviate it mph. That is the only one where you should be putting mph for, or you shouldn't put kph. It doesn't mean anything in the rest of the world. America is slightly unique in the fact that we still use miles and not meters. Let's see. Another thing was D versus capital D. So lowercase d is for distance. Capital D is for density. Again, capitalization matters. One of the major things I've seen on homework is y'all see a number, y'all just assign it to a random variable. In the future, I'll have one homework problem that will be something like this. You are traveling in a Dodge 1500, which is with red number 5 stripes. You pass a sign saying 55 miles per hour. The truck is half a meter off the ground. The truck driver has $22 in his wallet. The truck has 4 tires. And the truck traveled 5 miles past a 6 o'clock diner with a sign stating the temperature is 87 degrees Fahrenheit, and he did this in 0.1 hours. What is his speed? So, there's a lot of numbers in this problem. You have to understand what the question's saying. So we know that speed is equal to distance over time. You can't just randomly circle random numbers and just guess what they mean. So what distance did he travel? The truck has 4 tires, that tells us nothing. The truck traveled 5 miles. Again, random stuff. He did this in 0.1 hours. So I've seen a lot of people on the homework just randomly assign variables to numbers. You have to read the problem and gather what the variables that are important are and what they mean. This is a distance unit. That's how much he traveled. So his distance is 5 miles. And he did this in 0.1 hours. So his speed was 50 miles per hour, or you can write it as 50 miles per hour. So on the homework, I've seen a lot of people where they just took the first number, stored it as VI. They took the second number, stored it as VF. Took the third number, stored it as T, and took another number and did that. You have to actually read and look. Miles, that's a form of distance. Hours is a form of time. You have to actually read the problem and understand what it's saying. So initial velocity. Also, what's the difference between velocity and speed? Velocity has a direction associated with it. Velocity is your speed plus a direction. So it's how fast you are moving at the start. In a certain direction. Usually how we write the direction is positive numbers mean forward, and negative numbers means backward. So if I say you have a velocity of negative 55 miles per hour, it means you're going backward in reverse. So for the real physics class, we actually start doing east. We start actually making, and I have the students write out that you're traveling 22 degrees east. For this class, I simplify it and almost treat velocity as speed, but know that there is a distance, a direction associated with it. Whenever you're doing a problem, you have to ask yourself, if it's a problem dealing with acceleration, you have to ask, does it tell you what the initial velocity is? So if it says a car is at rest, blah, blah, blah. What this tells you is at the very start of the problem, it tells you that car isn't moving, that it is stopped. That tells you that the initial velocity is 0 meters per second or 0 miles per hour. Final velocity is the speed at the end. Not the end of the problem, the end whenever the end point of the where he stopped at, basically, how fast he's going at the end of the problem. This number doesn't have to appear at the very end of the words. So, for example, if I worded it, a car eventually reaches a speed of 55 miles per hour, but began at 20 miles per hour, this would be initial. It began at 20 and eventually reaches a speed of 55 miles per hour. Another thing that could appear up is a car comes to a stop. So a car comes to a stop tells you that the final is 0. It could be either meters per second or it could be miles per hour, wherever the problem is written. But sometimes it won't give you words, or it won't give you numbers. It'll just say a car comes to a stop. Acceleration. Acceleration describes how your speed is changing. Acceleration is how much the speed changes by. So if I wrote that a car is gaining 5 miles per hour every second, this is telling you that it is gaining 5 miles every second. That would be acceleration. We would write that as A equals 5 miles per hour per second. So another example, let's say if I said A equals 5 meters per second squared. This second squared is the same thing as 5 meters per second. You can expand that second squared out. This means you are gaining 5 meters per second every second. Or in other words, every second you are traveling 5 meters per second faster. Yeah. Yes. No. Let's look at VF minus VI. VF minus VI is change in velocity. It's how much your speed increased compared to your initial. Initial our starting speed. So this tells you how much your velocity has changed since the start. If you want to find your final would be wherever you started with plus your change in velocity. So it's your initial velocity plus your change in velocity. And how you, so if I give you a problem, another thing is a lot of you didn't use the triangle. From what I've seen is those who used the triangle mostly got it, did better than those who didn't. Some people didn't do the triangle correctly. So, if you have a triangle like this, and you're solving for change in velocity, you put what you circled first, then an equal sign, and then you read what's left. This is A times T. So these are next to each other, and they'll be next to each other on this side. If I instead solve for T, so if I solve for T, circle T, it'll be on the left hand side. Your A is below this, so it'll be on the bottom of the bottom, and this is over that. So it'll be VF minus VI over A. So let's do some examples. So you increase your speed from 5 meters per second to 10 meters per second, and was accelerating at 2.5 meters per second squared. How much time did you spend accelerating? First thing you should note is you are solving for time. Will your answer be in meters? No. Your time is either going to be in seconds, minutes, hours, days, weeks, months, years. How do you know which unit? We look at our acceleration. So our acceleration is second squared. So our acceleration is equal to 2.5 meters per second. You can expand that the second squared out into per second. We're solving for time, and then we're going from this, so from the speed to this speed. A lot of people just randomly plug that into either VI or VF. If you're going from this, that would be your initial speed. If you're going to this, that would be your final. So draw your triangle. We're solving for time, so it would be T equals VF minus VI over A. This over that. And another thing, look at your actual variables. I know another common mistake is y'all randomly, you did all this correct, you did everything correct, but then you just start randomly plugging this in. So this VF should go here under this. So that should be 10 meters per second goes into VF. Minus VI, or VI was 5. And our A was 2.5. Another thing is I see people get up to this point correctly. They set up their equation, they did their variables, everything's correct. And then they get some strange answer. Whenever you put this in a calculator, you need to put parentheses around this. If you can't plug it into the calculator, I suggest doing the top first. And again, the more you write out, would someone close the door, please? The more you write out and the more work you show, the less chances you are of getting something wrong. So I've seen some people write this out and type in the calculator wrong and get the answer wrong. So 10 minus 5 is 5 divided by 2.5. Plugging that in, that would be 10. And that would be 2. So 2. And we already said we're solving for time. So that would be 2 seconds. Box your answers once you're done. Another thing is I've seen some people writing the answers on the left. I told you on the left side is your given. All it needs to be is your given variables. You aren't given time, so your answer shouldn't be ever there. And then all your work and answer should be on the right hand side. Another common mistake is I've seen some people do everything right. For example, one problem asks how many miles you can go in like 41 minutes. So it said like 41 minutes, and you were going 55 miles per hour. They got an answer of 1.3. Is that correct? 41 divided by 55. Is that less than 1 or greater than 1? This number should be smaller than 1. What they typed in the calculator was 55 divided by 41. Again, you need to look back at your answer and see if you did it correctly. Think about it a little bit. So just one more example. You are traveling at 100 miles per hour and hit the brakes. You begin slowing down at negative 10 miles per hour per second. What is your final velocity? after 7 seconds. What is your final velocity after 7 seconds? So again, we need to read through this and see what we can identify. You are traveling at 100 miles an hour. That's describing your initial speed. You begin slowing down. Slowing down talks about your change in speed. Negative 10 miles per hour per second would be your acceleration. And 7 seconds would be your time. And it's asking you to find VF. In order to find your final velocity, you need to see how your speed has changed. So, you will first solve for your change in velocity. So we need to solve for change in velocity. Change in velocity is equal to acceleration times time. So that would be negative 10 times 7 seconds. So negative 70 miles per hour. You have slowed down by 70 miles per hour. So if you slow down by 70 miles per hour and you started at 100, that means you're now going 30 miles an hour. Your final velocity will be equal to your initial velocity plus your change. So 100 miles per hour plus negative 70 miles per hour, which is equal to 30 miles per hour. Once you've done this, the best thing I would say is go back and check and see if your answer makes sense. So if you are slowing down 10 miles per hour every second, and you're looking for what happens after 7 seconds, we would expect this number to go down, and we would estimate it to be somewhere around 30 miles per hour. I've seen some people put answers that are like 7,000 miles per hour. Think about that. If you're going 100 miles an hour and you slow down, hit the brakes, how would your speed increase? So once you get an answer, go back to the problem, reread it, and see if your answer actually makes sense. So are there any questions? Alright, that's it for today.